So yeah, welcome back guys. In the last video, I tried to tell you what I went through for the last couple of weeks. So I was basically exploring LangChain and LangGraph, and I shared a brief explanation or what concepts I went through. So today, basically, I'll be trying to explain what in detail about LangGraph regarding what is state, what is node, and what is edges. So as you might know, we are a technical channel or where I share my explorations and challenges that I face through my journey as an AI engineer or as an engineer itself. So if you're interested in technology, education, and a lot of dumb ideas, dumb projects, and whatever stuff I learn, please do subscribe to my channel as well as like this video. So let's get started. So yeah, LangGraph, state, nodes, and edges. As you might have seen in the last video, LangGraph is basically a structural, traceable, stateful LLM workflow. It is ideal for building tools, memories, agents, and conditional logic. It is inspired by state machines and data flow programming. So, what is basically a land graph? So, land graph could be a graph of nodes that transform and pass state, inspired by state machines and data flow program. Basically, you have a state. You can move that state or particular state into the next node, and you can make decision based on that state. And the state gets updated on each iteration. That's what happens in a land graph. So here, as you can see in this particular image, the data flows through the graph. The core concepts that bind the land graph together are state, node, and edges. So basically, state is a dictionary memory. It's like a dictionary that flows through the graph. It has the user input, LLM output, decision, etc., and it evolves as the just each node runs. So it basically holds the state of the whole graph, and it can be considered as a structured dictionary, and it's a mutable one. You can update the state after each iteration of the graph. Like if the one node is done, the state gets updated. If the another node is run, and the states get updated. So basically, LangGraph stores the state of the chain or the conditional flow or data flow in the LangGraph. That's what basically state does. If there is no state, you can say that the LangGraph loses that ability to say what happens previously in the past node, so that communication between or the nodes won't know what happened previously. So this is a basic example of a state. This particular state is a dictionary, and it has a couple of contents like user input, classification, response, like that. The second major component in a land graph is a node. So node is a function that performs one step in the flow. It could be like another LLM call, a tool call. It reads from the state and it writes the new state, state. So it can do major steps like classification, summarize, generate, call tools, etc. Node can be any function. You can write an method, and this particular method can, for example, here as you can see, here is an function classify state, and it has couple of classification including weather and unknown. So if the classification is weather, the state is updated as weather, otherwise it's updated as unknown. Then we have edges. Edges controls the flow of the graph from one node to another node. So edges can be of different types. It could be a straight linear edge or a conditional edge as well. These can be controlled using add edge function or add conditional edge function in LangGraph, and this makes the graph either sequential, looped, or conditional. And without the edges, as you might can imagine, the flow will be always sequential. Here, like I said, the flow is controlled by the edges itself. So if you are not stating the edge from the flow from one diagram to another, that particular flow won't be kept in the line graph. Then here we have example of an edge. Here it's a conditional edge itself. So the edge will decide to move to which node based on the condition of the weather. So here in the input, we will be classifying them based on the decision. So yeah, based on the decision, it will be moved to either weather or unknown. Then this is a basic simple example of a LangGraph. So as you can see, there is a state graph which has the two inputs like user input and the response. Once the first state is updated, we will generate a response from that particular state, and the nodes are connected from in a linear way, and once you combine it, the entire sequential graph will be completed. Then there is like couple of few advantages that we have while using LangGraph. That's like I said already, state maintains the context across the steps. It makes sure that whether the graph is traceable or not, what happened previously. The nodes can define or check what was the state of the current graph and continue based on the state. We can reuse the nodes really easily. It is testable using individual nodes will be testable, and we can scale. We can just add new nodes, add new tools, add them to new edges, conditions, etc. So these nodes, states, and edges helps in expanding the graph in a really good manner. Then yeah, these are some use cases of the LangGraph. Like you can build agents, tools, memory, control flow, custom chains, and there are also other methods like human feedback that you can explore. This makes sure that you can put an interrupt before a node, and you can get the output value from it. So the human can decide on the input, so that we will get a particular flow on if the particular condition is met. So these kind of things are included in LangGraph, and those are like really advanced things. I just wanted to explore the other features or really basic stuff like state, node, and edges for now. So if you are really interested in LangGraph from the last two videos, these two videos that I have covered, I will really suggest you to install LangGraph. It's really simple. Start with the basic ones. Continue building a higher or larger graph. Like for example, a booking application, like a hotel room booking application, or even a travel agent, or maybe even a calendar agent. It's really simple. You just have some API calls, make decision based on the availability of a person. Calendar agent will be a great example. Like for example, you can integrate your LangGraph to Google Calendar API. You can get a person's availability based on the calendar or the meetings that he have. So if somebody else want to build or connect to your graph and book a meeting with that person, the graph will decide whether the person is busy, if he is having any meeting at that time, and we can basically set up a timing and notification based on the availability of the person. So yeah, this will be a great example. You can try it out. A really basic graph is enough. So like I said, if you're really interested, stay tuned for the next video. Most probably I will be sharing a new project that I'm currently working on. It's a really basic project, not even an AI project. It's an photo sharing platform, not a platform yet, but you can share photos in it. So stay tuned. So if you like this video, like the video and subscribe to my channel. Thank you.